In this session, we're going to discuss evaluating a polynomial. If say evaluating a polynomial, we're going to determine what is the result of the equation of the polynomial equation when we substitute a certain value, okay, on that equation. So we have different approach, different ways in evaluating a polynomial to get the answer. Okay, since we have different approach, different ways, we need to determine what is the best approach. Okay, so what is the best approach? What does best means? Okay, for me, it means it will give us the right answer. Definitely, it should give the right answer. And second, the number of operations should be minimized. So if the original procedure is 15 steps, so if you could do it in 5 steps, it's better. Okay, so I'm going to choose the 5 steps. And third criteria is easy to implement. Okay, so give right answer, number of operation is minimized, number of steps is minimized, and easy to implement. That is the best procedure, the best approach, the best algorithm. And this concept is basically being implemented or being adopted in numerical methods. So to choose a certain equation, a certain approach, it should definitely should give us the right answer, should have less steps, and easy to implement. Okay, so that's why we are discussing evaluating a polynomial to have a grasp what's the meaning of the best approach. Okay, so for example, we have this equation 2 raised to 2 times 2x to the fourth plus 3x cubed plus 3x squared plus 5x plus 1 while x is equals to 1/2. So to determine the result, so this is how we're going to do it. Am I right? 2 times 1/2 times 1/2 times 1/2 times 1/2 plus 3 times 1/2 times 1/2 plus times 1/2 plus 3 times 1/2 times 1/2 plus 5 times 1/2 plus 1. Okay, so that's what we usually do. Okay, am I right? So let's count the number of operations. For multiplication, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And for the addition, we have 3. 1, 2, 3. Okay, 3, 4 rather. It's 4. Okay, so a total of 14 operations, 10 multiplication, and 4 additions. So is there a better way to do it? Okay, so let's discuss the second method. So we all know that we have x to the fourth, x cubed, x squared. Okay? So why not, let's solve first the x squared. So 1/2 times 1/2, we have the answer. And how do we solve x cubed? Since we have yung answer na ng x squared, why not choose it to solve for x cubed to minimize the number of steps? So it will be 1/2 times 1/2 cubed. 1/2 squared rather, to get 1/2 cubed. How about 1/2 to the fourth? So just multiply 1/2 cubed by 1/2. So we have 1/2 to the fourth. So why do we do this? Because when we evaluate the original equation, this will be our solution. 2 times 1/2 to the fourth, since we have this based on this solution. So we don't need to multiply 1/2 4 times. Okay? So just one, okay? Just one value. Same as with this and this. So how many operations do we have? 1, 2, 3, 4. Don't forget, we use this part, so it should be included on our solution. So 1, 2, 3, 4, 5, 6, 7. Now the multiplication is 7. How about addition? It's still 4. 1, 2, 3, 4. So we have 11 operations. So for method 1, how many? We have 14. So different approach will give us lesser number of operations. Okay? So let's discuss method 3. So instead of directly evaluating the equation, let's rewrite it. But rewriting means we factor out something, okay? Factor out x, okay? Or do the mathematical rule to get the factor form, okay? So in this, we factorize x. So from the original equation, we have this factor form, okay? So now, how many multiplications do we have here? So we have 1 here, 1, 2, 3, and 4. How about the multiplication? How about addition rather? 1, 2, 3, 4. So the okay, so the total is 8. Okay, so this is better compared to the method 1 and method 2. So different approach means different number of operations. So this is true to numerical methods. Different approach will give us different number of steps. Okay? So as the one that analyze the problem, we need to determine which is the best approach. So in this example, the best is based on the number of operation is method 3. Okay? So there's no um, there there's no the best probably method to in other examples and it depends on the problem given. It's not always method 3 is the best. Okay, there are instances you don't need to get the factor form, just tweak something on the equation and it will give us the less number of operation. Okay, so we need to know how to manipulate your equation to determine to lessen the number of operations. Okay, so this is basically a Nasa multiplication or corners method. So this is how probably we could determine the number of operations, less number of operation in evaluating a polynomial. Okay, so based on Horner's method, so n multiplication and n addition. Okay, so if they are equal, therefore that's the min max value. But there are instances we cannot get that. Okay, so as long as you could minimize it, it's better. Okay, so for example, how about this? Okay, so using the Horner methods, so we factor out what? X to the 5th, and then we could implement method 2. Okay, and then we have our result. So we could combine different approach to have a better solution. Okay, so that's evaluation of polynomial. So see you on our next video lecture. Thank you.